Namaste students. In our last lecture we have studied about different formulas of ellipse. In today's lecture we'll be doing some examples related to ellipse. But before we start with examples, let us recall all those formulas that we have learned. We have studied about two types of equations of ellipse. One is x square upon a square plus y square upon b square equals to 1 if major axis is along x-axis. And if major axis is along y-axis, in that case, equation is y square upon a square plus x square upon b square is equal to 1. A is always greater than b. Checking the value of a and b, we will be deciding which equation is to be used. Length of major axis is 2a always. Length of minor axis is 2b. Vertices, in first case it will be plus minus a0 and second case it is 0 and plus minus a. Focus points is plus minus c0 or c we also know it is equal to ae from the formula of eccentricity. So it will be plus minus ae0 and in second equation it will be 0 and plus minus ae. Directrix, equation of directrix can be written as x equals to plus minus a upon e. And here equation of directrix can be written as y is equal to plus minus a upon e. And length of lattice rectum we have studied, it is double of b square upon a. Let us start with first example. X square upon 25 plus y square upon 9 is equal to 1. And they are asking us to calculate all these values. Before we start, we have to check which kind of equation it is, whether this one or this one. Denominator of x is 25 and 25 is greater than 9. So bigger value, that is a, is under x. So this is the equation as denominator of x is greater than denominator of y. Therefore, we are having equation as x square upon a square plus y square upon b square is equal to 1. So, just like comparing a square equals 25, that means a is 5, b square is equal to 9, means b is 3. Relation of a, b and c we have learned, it is c square is equal to a square minus b square. So it will be 5 square minus 3 square. 25 minus 9, 16. So c comes out to be 4. Focus. In first equation, we have learned focus can be calculated as plus minus c0. So it will be plus minus 4 and 0. What is this in this case? Plus minus a0. A is 5. So this will be plus minus 5, 0. Length of major axis 2a. So 2 into 5 will be 10. Length of minor axis is always 2b. 2 into 3, that is 6. Eccentricity is c upon a, that is 4 upon 5. And if they ask length of lattice rectum, that will be 2b square upon a. So 2, b is 3. So 3 square is 9, a is 5. So that will be 18 upon 5. In second example, again they are asking us to calculate all these values: focus, vertex, length of major axis, minor axis and eccentricity. And here equation they have given us x square upon 4 plus y square upon 9 equals to 1. Now as you can see, denominator of y square is greater than denominator of x square. That means a is under y. That means this equation is there. So we have to compare our equation with x square upon b square plus y square upon a square is equal to 1. A square equals to 9 means a is 3. B square is equal to 4 means b is 2. C will come out to be 3 square minus 2 square. 9 minus 4, 5. And C will come out to be under root 5. Focus. In this case, focus will be, here it is plus minus C 0, here it will be 0 and plus minus C. 0 plus minus C. So it will be 0 plus minus under root 5. Vertex. Vertex points are 0 and plus minus A. So 0 and plus minus, what is A? 3. Length of major axis 2 into A means 2 into 3, 6. Length of minor axis 2B, 2 into 2, that is 4. Eccentricity is C upon A, that is under root 5 upon 3. So in two examples you must have seen that we have calculated same values, but according to the equation. First of all we have to check which equation is given to us. According to equation we have used the formula. In previous two examples they have given us equation and various values we have calculated. Here they have given us the value as vertices and focus and they are asking us to write down the equation. If you check vertex point as well as focus point, both are at x position, first position. So if you compare with these two, vertex would be plus minus A0 and focus will be plus minus C0. A comes out to be 13, C will come out to be 5. And using the relation of A, B and C, we will be writing B square is equal to A square minus C square. So that will be 13 square minus 5 square. 169 minus 25 will be 144. So B will come out to be 12. And if the values are first position, x position, so equation will be x square upon a square plus y square upon b square equals to 1. X square upon a square plus y square upon b square equal to 1. So x square upon a square, 13 square, 169 plus y square upon 12 square, that is 144 equals to 1. So, using the given values, we have obtained the equation of the ellipse. In example number 4, again we have to frame the equation of the ellipse. Here what they have given? They have given length of major axis as 20 and focus points are 0 and plus minus 5. As you can see, focus is on y-axis. X is 0 and value of y is given. That means it will be like this. That means our major axis is on y-axis. So equation will be y square upon a square plus x square upon b square is equal to 1. Here comparing, we will get C as 5. Length of major axis 20. Length of major axis we know it is 2a. So 2a equals 20. A will come out to be 10. C is 5, A is 10. And we know B square is equal to A square minus C square. 10 square minus 5 this also because we have to use b square only, or if want to write b as root 75. So equation is y square upon, therefore standard equation of ellipse will be y square upon a square. A means 10. So 100 plus x square upon b square. Root 75 square will be 75 equals to 1. Or it can be written as like this also, x square upon 75 plus y square upon 100 is equal to 1. Number 5, we have to again frame a standard equation of the ellipse. Here it is given that major axis is along x-axis and equation is passing through the given points. Major axis is along x-axis, so equation will be x square upon a square plus y square upon b square equals to 1. And equation is passing through these points. So in first case, put x is equal to 4, y is equal to 3. So we will be having 4 square means 16 upon a square plus y as 3, so 9 upon b square is equal to 1. First equation. And in second case, put x equals to minus 1 and y equals to 4. We will be having 1 upon a square plus 16 upon b square is equal to 1. That will be second equation. Now if we solve these two equations, by reducing method you can solve. Put 1 upon x square is equal to, say you are taking it as u, and 1 upon b square as v. In equation 1 and 2, so we'll be having 16u plus 9v is equal to 1, and from here it will be u plus 16v is equal to 1. So we can use elimination method. Subtraction. 256 minus 9. 247. And this minus 15. So v comes out to be 15 upon 247. And put v in this equation, we will be getting u is equal to 1 minus 16v. So 1 minus 16 into 15 upon 247. So we are getting 16 into 15. Minus 247, that means we have obtained as 247 minus 240, that will be, u will come out to be 7 upon 247. After getting values of u and v, now v is equal to 1 upon b square. V equals to 1 upon b square implies b square is equal to 1 upon v. So v square comes out to be 247 upon 15. Same way, a square will come out to be, a square is equal to 1 upon u. So it will be 247 upon upon 7. Now putting the values of a square and b square in this equation. So equation A we can say. From equation A, we are having x square upon 247 upon 7 plus y square upon 247 upon 15 is equal to 1. Reversing this equation, reversing these values, we will be having 7 and 15 here, 7x square and 15y square. So we have got the equation as 7x square upon 247 plus 15y square upon 247 is equal to